Hi, my name is John Berg. I'm with Century AC Supply and I do the training here at Century. Today we're going to talk about the need to check the capacitors on the compressor and fan motor. Many times the compressor can fail, not because of anything other than a weak capacitor. And that's one of the things that a lot of times we don't really look and pay that close attention to. It's very important to have the correctly sized capacitor in the unit and also to be sure that it is performing under a load as the microfarad rating states it should be. If we get close to 10% out of range, plus or minus, the manufacturer says the unit cannot work correctly. It's going to run hotter than it should, and eventually those windings are going to overheat and it is going to cause a failure. Now we've got a big problem. Checking for the little things is one of the things that helps us eliminate the possibility of the larger things happening, causing the failure of the equipment. First, we're going to have our unit here. We're going to talk about what we're going to need. We will need a voltmeter, a multimeter. This one in particular is able to use and check microfarads, but we're also going to be using it for both volts and amps when we're actually running the unit and checking it under a load. Don't forget, in all cases, we want to practice safety. I'm wearing glasses today for eye protection, and I'm wearing my gloves for protecting my hands. We'll start with first making sure that we have the power off of the unit. The disconnect is closed, but what we will be doing is again checking our incoming power to ensure that we do not have any power on the system by checking our two leads coming in. We do not, and then taking individually each leg to ground, and again we have 0 volts. Now, the conventional way has always been to disconnect the capacitor and remove it and check it while it's out. As you can see, sometimes removing a capacitor takes a little bit of time and effort to do it. This is one of the things that we will be saving a tremendous amount of time when we have the unit running and we check it under a load. But this capacitor being out, its rating is 35 microfarads for the compressor, 3 microfarads for the fan motor, and it is a 370 or 440 VAC rating. That means the minimum rating is 370, which is usual, very standard, and 440 is just a little bit heavier duty. It will withstand some surges and higher back EMF, which is what we'll be using and taking a voltage reading. In checking now, what we do is we set our voltmeter to microfarads. And between, this is our black lead here, and Perm, we hold the wire between those two, and we see that this microfarad under static is reading 35.0 microfarads for the compressor it is reading 2.8 microfarads for the fan capacitor. This would indicate that this is well within the 10% range of 35 by 3. We're going to reinstall this capacitor, and now I'm going to show you a very easy way of doing it. Now, my suggestion is if you are replacing a capacitor, before you replace it, check to ensure that even the new capacitor has got the correct rating. There's always a possibility that we get something and it's not going to perform to standards. So check that first, but we're going to install this again, and then we're going to find an easier way and by far a more accurate way of checking our microfarads. With the unit back together again, let's find out and see an easier way. Now, there's nothing wrong with checking a capacitor that way. That tells us under static, no load. Would be the same as taking a battery and checking the voltage without the light turned on, or on your car without it trying to start the engine. Under a load, a capacitor may react very differently, depending on outside temperature. The hotter it gets outside, if we have a weak capacitor, the more likely it's going to have reduced microfarads. That's the worst time to put that compressor under stress. The hotter it is outside, the harder it's working, the more efficient the system can be. The correct capacitor will ensure longevity to the unit. But again, going back to checking it under a load, we have a sheet here. Find it online, www.centuryac.com, and it is what we call the true run capacitor test. What we're going to be doing is we are going to take a volt reading between start and run, which is the two legs of our capacitor. That's going to be a volt reading. And then we're going to take an amperage reading on the purple wire, which in this case is the wire that goes to the start capacitor. When we take those readings, the volt reading we'll find on the left-hand side in red. The amp reading we will find across the top in blue. And where the two lines intersect, that will tell us, with that compressor running, what the microfarads that capacitor is producing. Let's go ahead and turn the unit on now, let it start running, let it stabilize, and then we'll take our readings. check our voltage. We turn the breaker on, but we still want to check our voltage to ensure that we do have the adequate voltage for the compressor. We're rated, this unit is 212 volts incoming current. This is a 208 volt primary circuit coming in, so we're well within the range of 10% of 208. We'll turn the unit on. We'll let it run for a couple of minutes. Now we're going to find a much easier and a more accurate way of checking the capacitor, but while it's under a load. We're not going to have to disconnect, we're not going to have to pull wires apart, we're not going to have to remove it. All we're going to have to do is simply take a volt reading between common and term on the capacitor, that reading being 3/16. Then we will take an amperage reading on the common wire going to the start winding, which is 4.19. Using our chart, we will look up 315 and 4, and those two numbers intersect at 34 microfarad. This was and rated a 35. As you can see, under a load, we're getting a more accurate reading of what this capacitor is doing under a load. How about the fan motor? Let's do the same thing for the fan motor. Taking the common to fan, take the fan motor. Taking the common to fan, we have 312 volts. Changing to our amps, the start winding, the brown wire coming off, is 0.33, 0.34. Now, we look on our chart, and we don't have those numbers lining up. They're too small of a number. Well, what we can do is any reading we take that does not have and fall within the 315 to 445 voltage, 2 to 13 amps, what we will do then is take and use a factor where we put the amp draw of 0.33 times a fixed number of 2654 divided by the voltage, the applied voltage, which we took at 311. And that number there will give us under a load what this capacitor is actually producing when it's running. We may find on a 95 or 100 degree day it may be working differently than on a 65 degree day, depending on the weather and the load conditions. Remember, our job and your job is to find easy ways of doing this. Knowledge is power. Knowledge is the ability to know how to do it in a very efficient, proper method. Correctly diagnosing is a key factor. Anytime we're out here checking an AC unit, we should be not only finding what is the problem with the unit, but we need to be also looking at seeing what could be causing the problem or where a possible problem can be cropping up. Loose wires, loose connections, checking capacitors takes a very short period of time. And my thought is always, which is easier? Checking a capacitor using this method, fixing it before it takes the compressor out, or not checking it, and on a 95-degree day or 100-degree day, we're out there in the middle of the summer changing a compressor or a unit. Very small things create very large problems.